Okay, in Chapter 1 we looked at linear modeling and regression, and now we have studied a few other types of equations, so we want to see about other types of modeling. Maybe the data doesn't have an exact linear pattern. Maybe there's a better kind of equation. In this problem here, I've got the age of a dog compared to human age, and I want to see I want to come up with an equation that will model this and give me ages for things that aren't listed in here, like maybe 5 or 15 or 20. What I would do is I'm going to start the same way as we did before. We're going to go to Edit, and we're going to enter all of our information in List 1 and List 2. If you want to pause a moment, get that into your calculator, and then pick up when you're ready. Once you've got that in there, make sure that everything is exact, because one mistake will throw off your whole problem. You want to get out. You want to go to y equals. If you have equations in here, go ahead and clear those out so they don't mess up your picture. And you want to turn on your plot 1 by highlighting it. And then let's go to zoom and go down to number 9, zoom to stat, and that will automatically adjust our windows so that we see all of our data points. So we've got these boxes here, and yeah, that looks kind of linear, but there's also a little curve to it. So linear might be a good fit, but there might be one that's better. How we find that is we're going to get out of there, quit. We're going to go back to stat, and we're going to have it do the calculating for us. Just as before, we want to try linear regression first, maybe number 4. Hit enter again. And then it gives me the y equals ax plus b equation with a equals the 4.55 number, b equals the 10.306, blah, blah, blah. R squared is the coefficient of determination, telling me how much of the data is explained with our model, and R is the correlation coefficient, telling me how good of a fit it is. Well, for most models other than linear, all we're going to get is the R squared, so we're going to use that as our comparison. In this case, it's 0.991 or 99.1%. That's pretty good. If I wanted to come up with an equation, maybe to write down what the linear model looks like, I would do a little rounding and call it y equals 4.55x plus 10.31, right? So what is a better model, or is there one? Well, let's go back to stat, and this time let's go over to calculate and choose number 5. Let's see if a quadratic or an x squared equation might be a better fit. Again, you hit enter twice, and it gives us the y equals ax squared plus bx plus c equation with a, b, and c as given there. This time our r squared is 0.9925, so we're getting a little bit better fit. I could round again if I wanted to copy down an equation that I wanted to write down on paper, or so that I could choose the answer in the math lab. All right, one more. Let's try a cubic. If we go back over to stat and then calculate and choose number 6, cubic regression, here we go. And it's going to give me an ax cubed equation with a, b, and c and d this time as my letters to fill in, and our r squared is now 0.996, almost 0.997. So this is the best model. Here on the side I have what I would get if I'd round those off, what the equation itself would really look like. Rather than having to use the rounded off model, let's go to the y equals and let's paste what we just found. So bars, and we want to do statistics, and we're looking for an equation. So go over to EQ, and we want that regression equation. It pastes it all in there for me. Now if I wanted to use this model instead of the rounded off model that we had written down here to estimate how old a dog that's equivalent to, or like a 5-year-old dog, what that is equivalent to in human years, we would get out of here, and we want to treat that y variable as a function. So go to vars, go to your y variable, choose function, and which one? Well, we paste it into y1, so choose y1, and it's instead of f of something, it's y1 of, let's say, 5, and hit enter, and it tells me a 5-year-old dog would be equivalent to about a 36-year-old person. You could do that for other values. You could do y1 of, let's say, 15. 15-year-old dog, according to this, if we round up, about a 76-year-old person. If you have questions, go ahead and email me, but I hope that helps.